Okay, can everyone see and hear me?
Mm-hmm.
Yep. Well, I can't see you, but I can see the slide.
Yeah, okay, cool. All right, I guess we'll just wait just a few minutes, or actually, I guess we can get started since it's 1. So hi, everyone. It's Rajani and Rachel. We will be hosting today's 27th Town Hall. So with a full agenda, let's kick things off. And first up is Jared.
Cool. Yeah, thanks. So basically some updates on my side. Unfortunately, there isn't too much to get into in terms of the project future, but I didn't want to keep you guys in the dark. Carl and I have been pretty busy basically flying around and meeting with different potential investors and other ways of seeking how to raise funds. We're considering putting more of our own personal money into it. We've been talking about doing some private OTC trades with some other individuals that would probably come out of Carl and I's team allocation in S&T. We've also been revisiting how equity may make sense, and if that does make sense, then that also might be a potential way to raise more funds. It didn't make sense in the past, but it's unlikely, but it's an option, and we continue to find other sort of avenues and that sort of thing. But just giving you an idea that we are working on this sort of stuff, and been going through a ton of meetings. And I think the main running theme is a lot of investors basically just want to stake S&T or stake some kind of token and essentially get some return on it for free. Of course, you can't actually do this entirely for free. There's regulatory reasons for that. But basically, we start talking about means that people can put their tokens up for things and provide, either creation or like hosting of nodes or hosting of the network, and even the user acquisition engine. The user acquisition engine is something we haven't talked about in a while. And it's pretty much like one of the last sort of S&T things we should do, and I'll talk about that in a moment. Next slide, please. So basically, the reason we're focusing on all the S&T white paper promises is because that's really what our focus should have always been. The reason we haven't is because scaling seemed a lot further away, and we've seen we had the runway to get things right and really consider these things. Of course, it makes a lot of sense for us to refocus now under the current market conditions. But it's important to realize that the network and the utility of that network is our major asset. So that predominantly relies in network incentivization, basically for the same reason I just mentioned, that you can essentially stake your S&T, or you can you can create a service network, and there can be different ways that works, but we're all working on them. We're all kind of aware of them, whether that is like clients, proof of uptime, or proof of or some kind of slashing conditions or reward for providing good data, incentivized messaging, which is a lot of the new protocol work we're looking into. And of course, if we want to maintain push notifications, that probably still won't fit inside the new protocol framework, and it might have to be like an extra service that people have to pay for on top of that. Now, the other one is the user acquisition engine, and I basically already went over this, but all the S&T use cases that we're doing are essentially supportive functions of the acquisition engine. And yeah, we're basically working on this last because we need scalability for this to really work. The idea behind this is essentially, actually, I'll go into that in the next slide. Please, yeah. So Carl and I, before we started Status, we run a few different businesses together. But one of the more interesting ones that we did was essentially paid user acquisition. So the idea here is essentially there's a publisher who's either created some software or some kind of service, and they essentially want to outsource their marketing. So they find people who have a distribution network or are capable of acquiring installs or acquiring cost per actions. So the idea is that they're willing to pay a nominal amount, say like anywhere between like 20 cents to $5 for an install or for an action. And they're willing to pay for that because they expect the lifetime value of that acquisition is going to be more. So there will be some kind of margin of return on that acquisition. So the problem we identify with this is that it tends to lead to fraud. Basically, the marketer essentially can, as long as the marketer convinced the publisher to pay, then they win, right? So there's these problems of like creating like fake installs, and there's these problems of like basically fake installs. And the reason this comes up is because also the payment cycles are a bit different. So for example, marketers might be expected to be paid net 30 every 30 days, whereas the lifetime value of that user might not be realized entirely until like 90 days or even longer. So what's kind of interesting about this is we can actually democratize this whole model, and we can kind of marry the idea of organic growth in an application with paid growth. And we do this by essentially allowing users themselves to get rewarded by S&T or get paid for onboarding their friends or family or whoever they want to do. And what's also, how this essentially works, well, the actual details of this will work are a little undefined. I did go over this idea a long time ago, but well, it feels like a long time ago now. But the idea is essentially that the friend or the seller can essentially stake the amount of value that they think a potential new acquisition, a new install would cost or is worth. And then you have these validators that can essentially play this prediction game against that. And someone is staking S&T willing to buy these installs, and everyone can get paid and people get slashed and that sort of thing. Won't go into the details too much. But yeah, thanks. And what's also kind of interesting about this is I actually realized this could potentially solve the onboarding issue of getting tokens initially. So for example, if there is a margin between the amount that somebody say like I want to make I have you as a friend and I want to bring you into status, but I know that I can increase the value of your you on jumping into status by giving you S&T, because that means or F or any other token, because that means you're more likely to use the application. You're going to have less hurdles. So you can imagine that I could essentially bring you into status. I tell these validators and the people who are buying the installs that you're worth this amount. And the reason, in addition to securing my bet on you, I can also send you funds because it works out that you're going to stay around the application a lot longer because you have a smaller barrier of entry because I basically gave you tokens up front. And the reason I'd do that is also because I will get compensated for that install. And what's also kind of interesting about this is there might be an opportunity to actually make the reward that to the person who's staking or buying these installs to actually mint tokens. So it could be inflationary, which is kind of interesting because then that means as the network grows, there's going to be more tokens to service the entire community. But then if we create all that other S&T use cases to be deflationary, then you can imagine the use of the actual network is going to cause the the individual tokens to be worth more. So basically, you get this kind of really interesting sort of curve where, like, the more people are onboarded, the more tokens there are. But then, if growth starts stopping, then the network has continued to be used, then the tokens will go in value, which then drive further growth, potentially. Anyway, so this is something we're going to start thinking about a lot more. And after we get these current S&T use cases out of the way, we're going to start working on the user acquisition network, engine. And the other part here I wanted to mention, now the point's eluding me. That's right. What's kind of interesting about this is that then this drives the feature development of Status itself, because people are going to only want to bring more people into Status is if they can get higher retention rates of the people that they're bringing in. So the more profitable it is to bring people into Status, then the more people are going to do it. So you can imagine that, okay, like onboarding is going to have to be really, really tight. The way of retaining users within the application is going to become tighter and tighter. And a lot of our focus will end up be put onto this. And the other reason, the other issue here is scalability in general. This might actually start forcing us to find scalability solutions a lot earlier, but we don't know about that yet. Anyway, next slide. So another thing that we've been, it's been a bit of a hot topic, between JB, Kerry, Nabil. We've been trying to figure out ways that we can basically do performance management or peer review. We've been thinking about this for a while. We've had a few different discussions come up and discuss. There's this idea, there was ideas of doing stack-based ranking. There was ideas of having some kind of leaderboards based on whatever metrics, but a lot of the feedback hasn't been that great. But what did kind of work for us was the Kudos in Slack, if you can recall that. So we're looking to essentially do a similar thing like that, but with a difference in Status that you can essentially earn S&T from people giving you Kudos. And there's going to be a Discuss post coming out by JB and Kerry. It'd be great to get your feedback on that when it does come out. I started writing the contract based on some of the specifications on the weekend. Hopefully it'll become an extension within Status, and perhaps a little DApp, but that depends on your feedback as well. Anyway, I just wanted to raise this point so everyone's aware about it, and definitely look forward to your feedback. Anyway, that's it from me. Thank you.
Super cool. Bring back Kudos. Thanks, Jared. So great to know what we're thinking about for the next stage of the project, especially given the fast progress that the teams are making on all of these S&T utility features. So we're going to do a quick update on each swarm. I think first up is Tribute to Talk. Is Eric on the line? Okay, promoting you to panelist, Eric. Are you there, Eric?
Can you hear me?
Yep.
Okay, so yeah, so far the screens for setting UI, the screen for setting the Tribute to Talk in the UI are in peer review. And soon the contracts, it's going to be connected to the contracts for testing. So then what's left is the chat part of the flow. So that's it for Tribute to Talk itself.
Okay, thank you. Next up, I think we have Sticker Market. Is Julian here?
Yeah. So we made great progress on the UI implementation, and essentially all the flows are implemented. What we did recently is implementing the purchase workflow so that you can buy and install new sticker packs. And also we implemented the recent stickers features. So actually, there is some small video. Maybe it could be interesting to start right now the video. Right. Okay. So yeah, you can see that now we start with an empty panel. Then you can browse the existing packs, and you can decide to install whatever packs you want. And then once your pack is installed, then you will get access to those stickers. So there's like an extra item on the bottom part. And you can then trigger whatever stickers that you want to send. And each time you send a sticker, it will appear in the recent panel. So it's kind of an easy way to list your favorites or recent stickers that you send without having to browse the original packs. Right, so that's pretty much the whole UI implementation. So we still have to nail and to polish the implementation, no? Because it's not like completely accurate according to mockups, but we will get there soon. But then we also worked on the contract, and it's essentially implemented and finished. So yeah, it's just a matter of having Ricardo, well, this like validate that the contract is correct and publish it on Ropsten. And then we will be able to start experiment. And that's essentially the last step that we have is to, well, first make sure that the UI is completely finished, and then to integrate with the contract. Yeah, because right now everything is kind of hard-coded or using like default cat packs, but we want to make sure that, yeah, of course, it has to work with the real contract. So that's the next step. And the last bit is that, well, we are in contact with artists to create sticker packs. And I think, yeah, so here Rachel is talking with different artists, and I think we are we are making great progress and to have those nice stickers pretty soon.
Yep. There's actually a new doc in the Swarm folder as well with progress on the sticker search, the Illustrator search. Thanks, Julian. So next up is Teller Network. Yuri?
Hello. So Teller Network, we made very good progress. We have prototyped the DApp. We have the prototype DApp deployed to Rinkeby, which can be accessed through GitHub pages. We're currently basically changing the UI of the DApp to comply with the designs that were provided to us by the design team. And we're also adapting the workflow of the DApp to work with that. We discussed a lot a specification for a better arbitration protocol. And one of the requirements is a communication layer that the DApp will need. And so for that purpose, we made Murmur web compatible, which is really amazing. And we'll see later in the Townhall, Richard will talk about this. And besides all that, there was lots of improvements and bug fixes here and there. And essentially ensuring that the DApp is solid from the get-go and not something we look later at the end. So it's fully tested. We make sure everything has acceptance tests, internalization support, and so on. And you can access that link, the DApp, as well as the storybook.
Fantastic.
Needs to be Rinkeby though.
Okay, and next slide is DAO. Do you want to take that one as well?
Yeah, so the DAO, the liquid funding itself is in the implementation phase. One of the issues we had, which we also have in the Teller network, and it's a very common issue in dApps, is that we needed the event sourcing and also persistent solution. So what we did is that we did such a solution using Watermelon DB. And this gave us much faster load times. It gives us a very, very flexible querying for our DApp. I know that we have this solution. We will likely be implementing it in the Teller network as well. And Barry has been the main developer pretty much working on this.
Cool. Thanks, Yuri. Next up, is Igor available?
Yep. So yeah, network incentivization. So we are still in the research phase as was planned. So one of the big milestones this time was the protocol workshop in Brussels, because we wanted to figure out how our requirements will be set up. So we ended up thinking that we essentially don't want to be bound by Whisper, but we are not looking that much into the protocol specifically because it's more like a long-term thing. And yeah, we are started to prepare the draft of how this incentivization might look like after researching different documents. So yeah, that's from my side.
And I think there's one more slide for you. Next is core improvements.
Oh, right. Yeah. So we moved for these 2 weeks, we moved from like 9 to 19% of our backlog completion, but we will also have a backlog refresh meeting this week, so this number will most likely change. So yeah, as you can see, almost you see what's epics are in progress. These are mostly similar that were there before, but yeah, we did a progress in each of them, but we are still we finding some issues with message reliability, for instance, and we're trying to fix them. So it's taking some time, but yeah, we are getting there.
Okay, nice work. Thank you. So next up, Oscar's going to give a bit of an update on the protocol work, but first I just want to leave time for Q&A on Swarm updates. And it looks like there's a question in here from Jacek. Jacek asked, the Swarm cost so far, why is it not in ETH? Maybe Nabil or Jared, one of you could speak to that?
Yeah, right now, because salaries aren't paid in ETH. Sorry. Because salaries are right now paid in USD. The cost is in USD. Once compensation moves to ETH, then it's much easier to calculate in ETH. We could calculate in ETH just by doing a conversion. I think if that's preferred. I just think right now it's easier for people to grok USD than ETH, considering the price fluctuations that we have.
Yes, we can definitely figure out what it is in ETH as well. We can find the market price for each, say, Townhall cadence, and then aggregate each of those ETH equivalents up to find out exactly what that looks like.
Makes sense. Thanks, guys. There are no questions from YouTube. So if there are no other comments or questions, then I think we can move on to the protocol update. Oscar?
Yeah, sure. So this week we had last week we had the workshop in Brussels. A bunch of people were there: Jacek, Corey, Yuri, me, and Anthony, as well as people from Web3 Foundation, Validated Labs, Matrix, and a few others. And then we also done Core and I, we worked on a secure messaging evaluation that I'll talk a bit about later. Next slide. So first of all, what is SES trying to do? And we're trying to create a kind of secure communication tool that upholds human rights and enabling community-based money, community-based law, and through privacy, preserve culture, and empower individuals to make choices and socially coordinate. And a lot of this is what Jared alluded to in the beginning as well. I guess next slide. So why work on this protocol effort at all? What's the point? Several reasons. So first is it allows us to make solid guarantees about what our set of protocols actually do. Because if you want to be secure, you need to be able to reason about that as a standalone thing. And it also allows other people to look into it and analyze it that is not tied to any specific code base. And there's also a cultural shift in terms of thinking about the protocol as its own being, and having it be language independent and clear specification. And this also doesn't just touch the Whisper or whatnot. It covers the whole stack, and it's multiple layers. And this includes SNT use cases and everything that powers the status network. And also it clarifies our role a bit more, similar to the Ethereum Foundation and Ethereum, that we are this curator of this protocol that runs the status network, and we're building a reference implementation. In a way, you can say sort of that the protocol is an embodiment of our principles in various ways, as well as sort of parts of this. So, for example, the collaboration we're doing for finding a Whisper replacement is something that's useful for the large ecosystem as a whole. Next slide. So when talking about secure messaging, it's useful to try to break it apart. And one way of doing this is in terms of sort of orthogonal concerns. And there's a few ways you can slice this, but a fairly common methodology is to break it apart into at least 3 parts. But the first one is trust establishment. So that's sort of about, if I'm talking to you, how do I know I'm actually talking to you? And how does that initial key exchange work and all of that? And the second part is sort of when more in terms of safeguarding messages over the wire. So making sure messages are encrypted in various ways and so on. And then you actually have to move the messages somewhere. And a common sort of security goal is to look at privacy as a security feature. And to a large extent, hiding metadata such as who's talking to who and so on is a sort of security goal, and that's dealt with at a transport privacy layer, which right now is Whisper for us. And finally, you can also look at, this is maybe a bit less orthodox, but it's also because peer-to-peer messaging is fairly new, so it's not as well studied, but you can look at the peer-to-peer architecture and overlay we have as sort of a way to achieve censorship resistance and robustness and continuous and so on, because if you look at something like Signal, they still have, there might be secure messaging in some ways, but if their service disappeared, then you can't talk, right? So by having people hosting the infrastructure by themselves, it allows the sort of function to persist throughout time, and it's more robust to various types of attacks. So that's why peer-to-peer is extremely important to us, and it's sort of its own category in a way. Next up. So this is roughly what our current stack looks like for those who don't know. At the bottom, we have sort of the FTP protocol, which is what F and Whisper and so on runs on. And then we Whisper, and then on top of that, we provide confidentiality, authentication, forward secrecy, and so on with double ratchet and a few other similar algorithms. And then finally, we have kind of a bit of an ad hoc thing when it comes to providing one-on-one chat, group chat, public chat, and so on. Next up. So starting at the bottom, we're running DevPDP, and it has sort of, I guess I don't have to go into too much detail about this, but it has sort of a way to discover nodes, deals with sort of how messages look over the wire when you're sending them, has these different sub-protocols and like F and Whisper and Swarm and a few others, as well as sort of basic session management. Next one. So in terms of trade-offs, pros and cons, so it's definitely sort of battle tested as a default stack in Ethereum, at least. But it's something that people are generally trying to move away from. Ethereum 2.0 is going to use libp2p. Yeah, I mean, there's a few cons with DevPDP. So one is the encryption is broken, it's not going to be fixed. But there's multiple layers of encryption, but that's, yeah. There aren't very many transports supported, so that makes it hard to be censorship resistant, because aside from sort of cool things like we'll see Murmur, which is actually using libp2p to provide so you can run status in a browser, but DevPDP is built on TCP and UDP, and the sort of certain default ports that makes it so it's easy to sort of be blocked in public Wi-Fi's, and there's sort of no path to things like mesh networks and something like Tor, which uses pluggable transports to masquerade as a different type of traffic in order to run when you're blocked. So that's something that's very useful if we become more of a target. As well as sort of the distributed hash table that it's maintained is kind of expensive and slow on mobile, and there's a lot of workarounds that we do with that in terms of turning on and off the discovery protocol and also having sort of hard-coded peers and so on. And next one. So, yeah, I mean, most of you are probably familiar with Whisper. the initial idea was that it would be one of the three legs of the world computer. So Whisper would be for I/O, and then you have the consensus engine and storage. Yeah, I'm not going to go describe it into too much detail. I think in terms of time. So you can switch to the next slide. Something that's good about Whisper is the fact that it's actually default in Ethereum, and we're using it in production. But there's lots of bad things about it. So one thing is that the anonymity claims are not very rigorous, and it's not something that's taken seriously by researchers, people who are looking into privacy-preserving messaging, and for good reasons. And that's sort of both on the sender anonymity side as well as the receiver anonymity side. There's also no machine-readable spec, and there's incompatibilities between GEF and parity. The Whisper uses proof of work, which is really bad for heterogeneous devices, and that's something that's been known in the research literature for a very long time, and we're not even using it. So we're using like 1% of the proof of work, which means that we're not part of the larger Whisper network that barely exists, and it's also sort of easy to spam and so on. There's also no incentive to run a node, which is the reason that even though it's part of the Ethereum stack, it's not something people generally allow. And finally, this extreme scaling difficulties that make it so that it's simply not scalable. It's a bit naive in how it does things, and I think we're starting to notice it now, even though we don't have that many users. So that's a big problem. Next up. In terms of we use Whisper status in practice, like we're actually running like a centralized cluster. So we're not, if that's off, then it sort of doesn't work, right? We are not relaying, we just do partial relaying on mobile phones. Whereas in order to have the security guarantees as sort of specified in the Whisper specification, you need to relay all traffic, but that's just not possible on a mobile device and actually having reasonable bandwidth and battery consumption. You also touched on the proof of work. Mail servers are kind of outside of the core Whisper protocol, and they have to be up all the time, and it's a direct TCP connection, which means that you lose a lot of the security or privacy guarantees. We're noticing this now as well when there's some mail server issues, and that means that we have reliability issues. I'll talk a bit more about that later. I won't go into topics in chat because I think, people are fairly familiar with that, or it's not super relevant for other people. So can move on. So in terms of this sort of messaging evaluation, so this is an excerpt from a survey paper where essentially they take, this is specifically about transport privacy and a way to think about that and think about this layer where the concern is about getting messages from point A to point B or point A to other multiple points and sort of hiding the metadata. And you can look at sort of these different dimensions. So in terms of privacy guarantees, where you have things like sender anonymity and receiver anonymity, and also sort of usability and adoption, and thinking about these sort of different properties and reasoning about them at the specification level as opposed to in specific code implementation. And that allows us to choose better trade-offs and think more carefully about it. So this is what we've also done. There's a huge document where we have done, Core and I started work on it. We still need to finish it up, but we have essentially this type of evaluation, but for Whisper as well as for how we do trust establishment and conversational security. And it's a long ass document, but the idea is that becomes part of our sort of guarantees and the things that we know that we're providing, and we can communicate it clearly and not just wave our hands and say, well, Whisper is dark, but in reality, it's not, considering how we actually use it. There's a link to this document at the end, and we would definitely appreciate help from domain experts in terms of making sure this is accurate, and we can publish it on our doc site. Next up. And also, I'll go on to that later. So with trust establishment, how much time do I have? Right, so we essentially use these HT keys, which has Whisper and wallet key pairs. And then in terms of contacting a person, it's kind of trust them first use. So you find some user in a public chat or you message them, or you might use a QR code or ENS and so on. But we don't really have any kind of verification. It happens out of band. There are a few ways to deal with it, kind of web of trust kinds of things, or maybe enforcing that you have to meet up with someone and scan the QR code and so on. And all of these comes with sort of pros and cons, but it's something that we should be more rigorous about what sort of guarantees we have and what we are vulnerable to when it comes to man-in-the-middle attacks, impersonation, and so on. And there's also an opportunity here in terms of having multiple keys for dApps and many identities and so on, which is also a bigger debate in the Ethereum community of dApp privacy. Moving on. When it comes to conversation security, we're not doing too bad, actually. Largely thanks to a lot of the work that Andrea and others have been doing. Use double ratchet. A lot of this is of this Signal Open Whisper system stack, and it provides us with things like perfect word secrecy and integrity of message authentication and so on. There are some sort of small things that we still have to figure out. So, for example, the fact that perfect word secrecy requires back and forth messages. The semantics that we have around group chat are still fairly coarse, and it requires pairwise encryption as opposed to shared secrets and so on. So that's something we can improve and work on. And then, because we are sort of operating in this decentralized world, there's also some issues with social spam and moderation and so on. And this is where efforts like Tribute to Talk come in, but there's also other types of mechanisms that use SNT that we can use for this type of thing. And in general, the protocol and sort of status sort of want to make it easier to create these types of coordination mechanisms, whether it's coordinating over a multi-sig or having some kind of visibility stake, or maybe delegating trust to people for like temporary, like some kind of liquid moderation and so on. And next one. So one thing we're working on is sort of in terms of introducing a data synchronization layer. And the idea is that we are peer-to-peer application, and we don't want to have any central servers. And with the data synchronization layer, which is sort of an architecture that is very common in peer-to-peer applications. So BitTorrent uses a form of it, Git uses it, Briar, and so on, Matrix as well, Scuttlebutt. So the idea is that you have sort of nodes that have some state, and they have they sort of keep a kind of log of events that happen, and then they synchronize with other nodes. And these other nodes, in terms of the messages, they sort of have they communicate message dependencies, so the message they have seen, and then you take this together, and that's how you sort of get some kind of history that makes sense for you. The idea is that by having this type of data synchronization layer, it gives us more options. So it's kind of a in-between layer where you have this data synchronization layer, and then you allow sort of sync clients on top of this with semantics. And this is where you can sort of go wild and be creative about SND use cases and Tribute to Talk and these types of coordination mechanisms, because this provides sort of the reliability layer and just deals with data sync essentially. It also allows us to sort of swap out the transport underneath. So perhaps we aren't going to use Whisper forever, and then this would make it easier to do that type of thing and dealing with that, as opposed to being hard-coded to Whisper and tied to it. And it's assuming that that's sort of the underlying layer, so it's unreliable, delayed, and offline. So if you have problems with mail service being online all the time, that's hopefully would be less of an issue, because it deals with it's a sort of offline files, and it synchronizes once it's online, and it allows for sort of true peer-to-peer communication. Next slide. And this is just an example of what it might look like. So you could just sync with another mobile phone. In order to sync in the default mode, then both people have to be online at the same time. But if you send a message and then someone else is offline, once you're both offline, then you would have an opportunity to sync up. But you can also introduce other sort of nodes or mechanisms to ensure asynchronous messaging. So, for example, you could have desktop nodes that don't have high availability requirements, and it doesn't have to be a fully connected graph because you have some kind of group synchronization scope, and then you just sort of have these messages that you can sync up between nodes, essentially, similar to how BitTorrent works, where you download some file and then you see to other nodes within that file, essentially. Next one. So in terms of just visualization of what a future stack might look like, talked about data synchronization layer, adding that, and that's likely going to look something like Bramble Sync Protocol, which is from Bayer. And there's also a prototype of that. We'll sort of work on extending that. And then I guess in terms of layer below, metadata protection, that's something that might be something like a mixnet-based approach. And that was also largely what the workshop was about. So next slide. Yeah, so first, rough to-dos priorities. Want to introduce this data synchronization layer into the app, which allows us to experiment with transports below, as well as sort of having other types of mechanisms on top of it. It shouldn't require many changes right now. We'll try to sort of gracefully introduce it so it doesn't disrupt people, and sort of making sure it actually works before we turn it on. Killing our cluster and actually making sure that everything works. People can communicate peer-to-peer without it. And then sort of working on creating these sort of sets of open specifications with these guarantees that enables multiple implementations of status clients. And as part of this is also sort of finalizing the secure messaging evaluation I mentioned earlier. Next one. So for the workshop, a lot of it was based on mixed networks, and mixed networks are, I'm not going to sort of dive into it in any detail, but essentially a rigorous way of actually ensuring privacy. And there's been lots of exciting research in the last decade or so that makes them more viable. A lot of them are not based on sort of peer-to-peer decentralization architectures, and that's a lot of what the challenge is about. And we had lots of discussions about what those components are, rough ideas what solutions might look like, considerations like how you deal with mobile churn and how to think about latency, as well as sort of accounting for resources, sort of incentives, and making sure these are sort of privacy preserving and the mechanics make sense and it's efficient and so on. And we covered a lot of ground, and there's a long document about notes there, and that will sort of clean up and do a collaborative post with the other participants of that. And I think it's worth mentioning that this is very much a long-term effort, and it requires a lot of almost basic kind of research. So it's not something that we're going to introduce anytime soon, but it's if we are serious about privacy and actually want to provide these guarantees for our users, it's necessary. And this is something that people, both in the firm space, but also the Web3 general space, are excited about and interested in. So we've seen lots of interest and sort of want to work together with libp2p and so on in terms of building out this protocol. And yeah, it's exciting stuff. That's it for me, I think. I think there's nothing else after this. Next slide. Yeah, cool. So I guess any questions, and as well as if Corey or Jacek or Yuri or Anthony has something they want to add to this.
I got a quick something to add. Want to reiterate that the people who understand at a very fundamental layer how things work, like what key exchanges we do, how we may have adapted double ratchet for our specific use cases for decentralization, things like that. Please take a look at the SOK, the SOC evaluation of status notes, and give as many details as possible, because I want that to become the reference of what we say we can do and how we do it and why we can't do other things. Because all of the top line things in that graph that Oscar referred to in that SOC paper are basically security features, security and privacy features. And so if we can specifically say how we do these things, whether or not we provide them, the guarantees around them, and why we don't provide other things, then we can engage the academic community, because that's kind of a decent standard set of things that people look for when trying to evaluate secure messengers. And if we can start engaging the outside academic community and security researchers, then we can really start to have real strong feelings about why we do things. We can be included in the conversations, and it can help us grow quite a bit. So if you know things, please help me and Oscar contribute to that document so that we can get kind of a better outward discussion on how we work and why we work the way we do, and then fixing things that don't work quite so well.
This work also goes very much hand in hand with the extensions kind of thinking. We layer the protocol and offer it to developers in a similar way, which I think is a great feature for status time features.
Coming in kind of weak there, Jacek. Can you repeat that or relay it to Oscar? I think you're in the same room.
What I was saying was that the approach is very similar from a developer's perspective to our extensions work in the user interface. So the two things go hand in hand and offer for the developers on our platform options, basically. And I think that's a very powerful way to look at it, allowing developers on the platform to make choices that they would otherwise have to develop on their own. So, very good approach.
Okay, kudos guys. Thanks for the update, Oscar. To round things out, we have an update on Murmur and libp2p, which I think is Yuri.
No, we will be Richard speaking about it.
Okay.
Hello. Hey, so hello everyone. I'm really excited to present today what we have been working on for the last few weeks. A couple of months back, we decided to work on Status.js, a JavaScript library that would let anyone create their own status clients. Product of that effort, we built two Node.js applications, StatusX and Status.js Desktop. The next step was to make a Status JavaScript Desktop available inside the browser, which with the potential increasing adoption that this would bring. However, there was a big challenge, the Whisper availability, because most Web3 providers do not have Whisper enabled, meaning that dApps are not able to make use of this protocol. So Murmur is our approach to solve this problem via a JavaScript-based Whisper node. With Murmur, we have two main goals. The first one is to be a valid Web3 provider for Whisper that any dApp can connect to via WebSockets and send messages. Basically, you can run a Murmur node and have access to Whisper RPC methods and broadcast your messages via dep2p, which is the standard Ethereum protocol, and libp2p, which is the transfer protocol used by IPFS. As you can see here on this image, using the Murmur client npm package, in less than 10 lines of code, you can start and use a Whisper node. The second goal was to achieve browser support. In order to do this, we coded Murmur in JavaScript and used libp2p as a transfer protocol, making possible to achieve peer-to-peer communication inside a browser window. Next slide, please. So we found some technical challenge while doing this. You see here on this image the output of Murmur in Chrome console. Well, up until last week, this was not possible since Murmur was a Node.js application with no browser support. We successfully made Murmur ready for browsers by replacing all the native packages for pure JavaScript implementations, and now developers are able to import the npm package and expand their dApp functionality. Next slide, please. So another technical challenge we have is related to peer discovery. As you can see here on this diagram, we are currently using WebRTC with a signaling server. Client will connect to this server and will discover new peers. This is similar to Ethereum web nodes. This works, but introduces a centralized element and possible point of failure. We are researching on different discovery mechanisms, and there are some ideas on the table, so we expect to solve this soon. Next slide, please. And the next challenge is that since browsers cannot use dep2p and libp2p and dep2p are not compatible, You might be wondering, how can a message sent via libp2p reach nodes using a different protocol? In browsers, we are only able to use libp2p and send messages only to peers that accept this protocol. So messages won't arrive to status app or desktop unless the message arrived to a bridge node. Bridge are nodes that have both protocols enabled. As you can see here on this diagram, a bridge will receive a message from libp2p and forward this message to the rest of the P2P peers that they have available, effectively solving this problem. And vice versa, messages received via the P2P will arrive to libp2p peers. Next slide. So Bridge are Node.js application that can act as a Whisper node as well. Notice in this image how there are listeners for both protocols, and the peers are being added. These peers on the upper side of the screen are the P2P peers, and on below you can see a libp2p peer being added. Next slide, please. So finally, the next logical step in our quest was to convert the status.js desktop application to web, which was also done successfully. So we now have a web-based JavaScript client, status JavaScript web. This doesn't use plugins at all. It doesn't use browser extensions. It just works. You can play with it in the URL you see in the screen and see all the interesting features we have, like a smiley selector, being able to send images, YouTube videos, and all kind of cool stuff. But keep in mind that both Murmur and Status Web are both proof of concept. So it is expected to find bugs due to their experimental nature. For the next steps, there is still a lot of stuff that needs to be done, like retrieving messages from the mail server, storing them into a local database, as well as making things more efficient. So if you're feeling adventurous, contributions to this project are welcome. And that's it for me. Thank you.
I'd like to reiterate, we have no security guarantees around these yet. So don't put 12-word seeds that have a bunch of money in them when you're trying to test this out.
We did put a warning that if this is, we put like a very bold warning that this is a proof of concept and alpha, there will be bugs. And if someone wants something more stable, they should use the status desktop app. And the stuff that's there for putting the key, that's just for that purposes. And we try to make it clear in the DApp that that's the case.
Yeah, you also have a nice convenient one-time use generator for creating an account, which is nice.
Correct. That's what we should be using for now.
Oh yeah, one more thing is that I know that guys from East Denver wanted some kind of a web version for at least 2 public channels. Is it possible to set it up with this? Because yeah, so it looks like a perfect use case right now. It's just a read-only like archive of 2 status channels.
Yeah, you mean kind of like it's done with a Gitter iframe, but instead with status, with a particular status channel, right?
Yeah, we just need like 2 channels there.
Yeah, it's definitely possible. We're actually just thinking about doing that with Embark too, because in Embark right now, in the website we have, if you go to chat or something, that's the Gitter iframe, and we're thinking to replace that with just a status chat, directly to a status chat.
Mm-hmm.
And yeah, it's definitely can be done by adapting status web.
All right, does anybody have any more questions? Were there any questions on YouTube?
Nothing from YouTube.
Okay, any other questions before we end the town hall? All right, then. Thanks, everyone. Fantastic town hall. Thank you, Rachel, and I'll see everyone in 2 weeks.
Awesome, Johnny.
Thank you.
Bye, everybody.
Bye-bye.
Bye.
Bye.